Far out in the cold depths of our solar system, a tiny world circles the giant planet Neptune. This is Psamathe, one of Neptune's many moons. Unlike our own moon, which orbits Earth in a neat and tidy circle, Psamathe's path around Neptune is long and stretched out like a rubber band. This strange and distant moon holds many secrets, waiting to be unlocked by curious astronomers. Psamathe is considered a regular moon, just like our own. However, its orbit is far from ordinary. It's classified as irregular due to its unusual path and distance from Neptune. Imagine a tiny marble circling a giant beach ball. That's a bit like Psamathe and Neptune. Psamathe's discovery in 2003 added another piece to the puzzle of our solar system's formation. Its peculiar characteristics continue to intrigue scientists, offering clues about the chaotic early days of our cosmic neighborhood. In the vast expanse of space, finding a small, faint moon like Psamathe is no easy feat. It requires powerful telescopes and the sharp eyes of dedicated astronomers. In 2003, a team led by Scott S. Shepard made an exciting discovery. They were using a special telescope designed to spot faint objects in the night sky. To their surprise, they found a tiny point of light moving near Neptune. This tiny point of light turned out to be Psamathe, previously hidden from our view. Its discovery was a testament to the power of modern astronomy and the tireless efforts of scientists pushing the boundaries of our understanding. The discovery of Psamathe was a significant event in the world of astronomy. It highlighted the fact that our solar system still holds many secrets, waiting to be uncovered. Imagine a racetrack where some cars speed along the inner lanes, while others take a longer, winding route around the outer edges. That's a bit like the moon system of Neptune, with Psamathe being one of the rebellious racers taking the long and winding path. Instead of a neat and circular path, Psamathe travels in a highly eccentric orbit. This means its distance from Neptune varies greatly throughout its journey. At its farthest point, Psamathe is a whopping 46 million kilometers away from Neptune. That's farther than the distance between Earth and Mars. And to add to its rebellious nature, Psamathe also orbits Neptune in the opposite direction to the planet's rotation. This is called a retrograde orbit. Psamathe's unusual orbit is a key piece of evidence in understanding its origins and the history of Neptune's moon system. It suggests a past full of cosmic collisions and gravitational captures. Peering into the vast distance, it's hard to get a clear picture of Psamathe. It's a small and faint moon, even for the powerful telescopes we use to study the cosmos. Based on observations of how much light it reflects, scientists believe that Psamathe is likely made up of a mixture of rock and ice. This is similar to many other objects found in the outer reaches of our solar system, where the sun's warmth is a distant memory. Psamathe's surface is likely a dark and dusty place, bombarded by cosmic rays and micrometeorites over billions of years. Its small size, estimated to be around 38 kilometers in diameter, means that it likely doesn't have enough gravity to hold onto a substantial atmosphere. While we don't have a detailed image of Psamathe's surface, its icy composition and location in the outer solar system provide valuable clues about its formation and the conditions in the early solar system. Section 5. A Captured Wanderer. Theories on Psamathe's origin. So, where did Psamathe come from? Did it form alongside Neptune, or did it have a more adventurous beginning? Astronomers believe that Psamathe, with its strange and distant orbit, is likely a captured object. Imagine a cosmic game of billiards, where objects are flung around by gravity. One theory suggests that Psamathe was once a resident of the Kuiper Belt, a region beyond Neptune filled with icy bodies. A gravitational nudge, perhaps from a passing star or a collision, might have sent Psamathe on a course towards Neptune. Neptune's gravity then captured Psamathe, making it a permanent member of its moon system. Understanding Psamathe's origin is not just about one moon. It helps us unravel the broader story of how our solar system evolved from a chaotic cloud of gas and dust into the orderly system we see today. Section 6. Cosmic Cousins, Psamathe, and Other Irregular Moons. Psamathe is not alone in its unusual orbit. In fact, It belongs to a family of irregular moons circling the giant planets in our solar system. These moons, with their eccentric orbits and distant paths, are like the rebellious cousins of the more well-behaved regular moons. Neso, another of Neptune's moons, shares a striking resemblance to Psamathe in terms of its orbital characteristics. Both moons have highly eccentric and retrograde orbits, suggesting a shared history, perhaps as captured objects from the Kuiper Belt. Studying these irregular moons together provides valuable insights into the processes that shaped the outer solar system. They act as celestial time capsules, preserving clues about the early solar system's chaotic environment. By comparing and contrasting the properties of these distant moons, astronomers can piece together a more complete picture of their formation and the dynamical evolution of planetary systems. Section 7. A faint glimmer challenges in observing Psamathe. Observing Psamathe is like trying to spot a firefly next to a spotlight. Its small size and incredible distance from Earth make it incredibly faint, even for the most powerful telescopes. It's like trying to see a grain of sand from miles away. Adding to the challenge, Psamathe's surface is thought to be quite dark, reflecting very little sunlight. This makes it even harder to distinguish from the background darkness of space. Astronomers have to rely on long exposure times and advanced image processing techniques to even detect Psamathe, let alone study its surface features in detail. Despite the challenges, each observation of Psamathe, however faint, provides valuable data points that contribute to our understanding of this distant world. Section 8. Unlocking Neptune's secrets. Psamathe's scientific significance. Though small and distant, Psamathe plays a crucial role in helping us understand the Neptune system as a whole. Its unusual orbit provides valuable clues about Neptune's gravitational influence and the history of interactions within its moon system. By studying Psamathe's orbit, astronomers can model the gravitational forces at play in the outer solar system. This helps us understand how Neptune's moon system evolved over time and how it might continue to change in the future. Furthermore, Psamathe's potential origin in the Kuiper Belt makes it a valuable target for studying the composition and distribution of objects in this distant region. Each piece of information we gather about Psamathe, from its orbital characteristics to its potential composition, adds to the puzzle of our solar system's formation and evolution. Section 9. A distant future. Potential for exploration. Imagine a future where robotic explorers venture to the outer reaches of our solar system, sending back close-up images and data about these distant worlds. While Psamathe might seem like an unlikely candidate for a dedicated mission, its unique characteristics make it an intriguing target for future exploration. A spacecraft equipped with advanced instruments could analyze Psamathe's surface composition, revealing its true nature and origins. Such a mission could also study Psamathe's interaction with Neptune's magnetic field and search for signs of internal activity, such as geysers or ice volcanoes. While such a mission is likely decades away, the possibility of unlocking Psamathe's secrets keeps scientists and space enthusiasts alike looking to the future with anticipation. As technology advances and our understanding of the outer solar system grows, the possibility of exploring distant worlds like Psamathe becomes less like science fiction and more like a future possibility. Section 10. A tiny moon, a vast universe. Psamathe's enduring allure. In the grand scheme of the cosmos, Psamathe may seem like an insignificant speck of dust. However, this tiny moon, with its strange orbit and icy secrets, holds a certain allure for astronomers and space enthusiasts alike. Its discovery reminded us that our solar system is full of surprises, and there's still much we don't know about our cosmic neighborhood. Psamathe's story is a reminder that even the smallest and most distant objects can hold clues to the universe's grandest mysteries. As we continue to explore and learn more about Psamathe, we gain a deeper appreciation for the diversity and complexity of our solar system and the universe beyond. Psamathe serves as a beacon, urging us to look beyond the familiar and explore the unknown, for it is in the exploration of the cosmos that we truly begin to understand our place within it.